The neurobiology of stress. The neurobiology of stress is a complex and intricate process that involves a variety of biological systems within the human body. Stress is a normal part of life and serves as a survival mechanism that helps individuals respond to challenging or threatening situations. However, chronic or excessive stress can have negative effects on both physical and mental health. At the core of the neurobiology of stress is the body's stress response system, which includes the hypothalamic pituitary adrenal (HPA) axis and the sympathetic adrenal medullary (SAM) axis. When an individual perceives a stressor, such as a threat or a challenge, the brain's hypothalamus signals the pituitary gland to release adrenocorticotropic hormone, ACTH, which in turn stimulates the adrenal glands to release cortisol and other stress hormones. Cortisol is a key player in the body's stress response, helping to regulate metabolism, suppress inflammation, and mobilize energy resources. The SAM axis is another component of the stress response system, involving the release of epinephrine, adrenaline, and norepinephrine from the adrenal medulla. These hormones prepare the body for the fight or flight response by increasing heart rate, blood pressure, and glucose levels, and redirecting blood flow to critical organs. Chronic stress can dysregulate the stress response system, leading to prolonged exposure to stress hormones like cortisol, which can have harmful effects on the brain and body. Chronic stress has been associated with a variety of health issues, including anxiety, depression, cardiovascular disease, and impaired immune function. In the brain, chronic stress can affect the structure and function of key regions involved in the stress response, such as the hippocampus, amygdala, and prefrontal cortex. The hippocampus is important for memory and cognitive function, and chronic stress can impair its ability to regulate the stress response. The amygdala plays a central role in processing emotions and fear, and chronic stress can lead to increased amygdala activity and heightened emotional responses. The prefrontal cortex, which is involved in decision-making and impulse control, can also be negatively impacted by chronic stress, leading to difficulties in regulating emotions and behavior. Overall, the neurobiology of stress is a complex interplay of hormonal, neural, and physiological processes that influence how individuals respond to challenging situations. Understanding the mechanisms underlying stress can help determine strategies for managing and coping with stress effectively. This understanding also assists in developing interventions to decrease the negative impacts of chronic stress on health and well-being.